Hello everyone, this is Professor Audra Castonia going through some Week 3 tidbits. This chapter is all about solving linear equations. In this first portion of the video, we are going to review one-step and two-step equations. Now if you had to take the foundations class, this was stressed throughout the entire course. If you didn't, you may recall some of these same procedures as we go along. So once again, just in this portion, we're going to go through one-step and two-step equations. One-step equation is just that. It's one step. Now, we also mentioned that these are linear equations. What makes an equation linear? Let's pose that question as I'm writing out our first problem. A linear equation, if you graph it, which we will be doing next week, is just that. The graph is a line. And when we say line in math land, we are referring to a straight line. Saying straight line is being redundant, just so you know. Now, how do we know that an equation represents a line? Well, we look at the exponent on our variables. The exponent on all the variables would be a 1. In this case, here's our x. There's no little power up there, so that is assumed that it's a 1. Because if there's no number up there, it's the 1. That's the God of my math land. He, she, it is always with us, is how I always word it. Okay, so we have x to the first minus 12 is equal to 15. Now this is an equation because we have an equal sign. Each side of the equal sign contains what we call an expression. Now if the expression was there all by itself, the rules that we would follow would be to simplify that expression or evaluate it. We do that by using our order of operations, parentheses, exponents, multiplication and division together, addition and subtraction together, left to right. But because we have an equal sign, we are now making this into a balance. The left side is equal to or the same as the right side. Now when we were first introduced to the equal sign when we were kids, we just thought that that meant the answer. 2 plus 3 is. There was that equal sign. Now we're realizing that it's not about an answer, it's about a relationship. The left side is equal or the same as the right side. And now we want to keep it balanced whenever we do any maneuvers here. And our goal is to try to get x by itself. This is like an unknown canister labeled x. And when we take away 12, it's the same thing as 15. So we want to find out what's in that unknown canister labeled x. So this is a one-step problem because on the left side with our variable, there's only one operation with it. It's asking you to subtract 12. Now when you are balancing an equation, we want to make sure that we cancel things out. We want to get rid of this minus 12. Well, the opposite of taking away 12 is to give 12. Giving 12 is the same thing as adding 12. Because a negative 12 and a positive 12, those are opposites, same number but opposite sign. When you add opposites, you always get 0. And we want to get 0 because what's x plus 0? When you add nothing, you're stuck with what you began with, and that's how we get x by itself. Now we can't just add 12 on this side because now our equation wouldn't be balanced. So whatever you do to one side, you have to do the exact same thing to the other side to keep your equation balanced. The x comes along because we didn't do anything with it. Once again, a minus 12 and a positive 12 cancel each other out, and you have equal on the other side, your simple addition to get 27. Your answer is still an equation, x equals 27. Because you started with an equation, your answer will be the same. That's for a couple of reasons. To keep it similar, and it identifies my unknown, x, in case we have other letters involved. So x equals 27. That's an example of solving just a one-step problem. Now, we've had other one-step problems. We've had something like 6x is equal to negative 42. Once again, you have to identify what operation you have. We have 6x. When you have a number and a letter mushed together, it means multiplication. To undo multiplication, we would have to divide. So when you have just a number letter next to your letter, divide to get it by itself. Whatever you do to one side, remember you do to the other side. In this case, 6 divided by 6 is not 0, because then you'd be left with 0 times x, and that would go away. Any number divided by itself is 1. So now you have 1 times x, and 1 times anything is anything, and that's how we get x by itself. On the other side, I have a negative 42 divided by 6. When multiplying or dividing, if we have opposite signs, that's a bad thing. In other words, the answer stays negative. And there's our solution. Those are 2 examples of solving one-step equations. Now it's going to get on a little bit larger, and we're going to do some two-step equations. How does the two-step equations change or differ from the one-step equations? Well, let's start off with one. Say 4x minus 7 is equal to 37. Now you can see that on the left side we have 2 operations. Let's move that down a little bit for you. We have 4 times x, so multiplication, and we have subtraction. So there's 2 operations here, and that's why we call this a two-step problem. Now, we can go through and solve this a couple different ways or realize it. I can explain it a couple different ways. One thing you might notice is, oh, we have multiplication and subtraction. Order of operations says we do the multiplication first. That's true when you are simplifying expressions. As we stated before, though, this is not an expression because it has the equal sign. This is an equation, which means that we do different steps. We're actually undoing all of our order of operations and going backwards. So kind of like looking in a mirror and walking backwards to find those keys. So we're actually not going to do the multiplication first. We deal with the subtraction first. But we can't just subtract more. I need to cancel it because I'm moving it from one side of the equal sign to the other. So I have to do the same thing to both sides to cancel it out. So when solving, the first thing you're going to do is the addition or subtraction, then do the division to cancel the multiplication. That's always our order in a two-step problem. Another way of looking at that is we have 3 terms in this equation. Remember, terms are things that are separated by addition or subtraction, also equal signs. It's really important that you understand what is a term and what is a like term. Terms are a number, a variable, or a product, meaning multiplication, of a number and variables separated by addition. So in this case we have 3 terms. The first term is 4x because it's 4 times x. That's that product. Then it's minus. Well, we said separated by addition. Correct, but remember, subtracting is the same thing as adding a negative. So this is really adding a negative 7. So our second term is negative 7. The equal sign stops that term, and then on the other side we have one term, 37. So we have 4x is one term, negative 7 is the second term, 37 is the third term. 2 of those terms are what we call like terms. Like terms have the same variables raised to the same exponent. That's the 2-part criteria. Let me state that again. Like terms have the same variables raised to the same exponents. Now in this case, we only have one variable, it's in 4x. Well, technically the negative 7 and the 37 have a variable too. It's just raised to the 0 power. They are both like terms because they don't have variables. So we want to get the like terms together on the opposite side of the equal sign than the term that has the variable, the unlike term. So in this case, the first thing I'm going to do is add the 7. Get that term that's not like the 4x away from it. Once again, whatever I do to one side, I do the exact same thing to the other side. A negative 7 and a positive 7 makes 0, which is what we want. That's called the additive inverse, is the positive 7, and when we add and get 0, we get the additive identity. It's important to get the identity because it doesn't change what we started from. 4x plus 0 is still going to be 4x. Add over here, we end up with 44. Now we have the multiplication that we have to undo. We undo the multiplication the same way we did before by dividing by the number in front. Whatever you do to one side, you do to the other side. Multiplying and dividing by the same number, those are inverse operations. And the result is the multiplicative identity of 1. 1 times anything is anything. No, you don't need to know all those nasty words like multiplicative identity or additive identity. I'm just letting you know that there is a mathematical reasoning as to why we are doing the procedures we are doing. And get your answer of x equals 11. Now, you don't have to take my word for it that that's the correct answer. You can check all of your answers, and that's the important feature on solving equations, is to remember that you can always check. If you go back into your original, we had this 4x minus 7 was equal to 37. We now know that x is 11. It means the same thing as 11. So in this equation, I can replace the x with 11 because they are equal or mean the same thing. So I'm going to go through here and replace my x with the value I came up with. So I now have 4. Now I have to indicate multiplication, so I'm going to put parentheses in to indicate multiplication. If I don't, if I just leave it not without a symbol there, it's going to look like the number 411. So be very careful there. You can use the multiplication dot as well, but oftentimes with all the numbers, the multiplication dot gets lost. So I don't want to do that. So I'm just going to use parentheses. Now I'm simplifying this side of the equal sign. Because I'm simplifying, that's when we use the order of operations. So to simplify that, I would do my multiplication first and then the subtraction. Multiplying, we get 44 minus 7 is equal to 37. Then we take 7 from the 44 and we end up with 37. The left side equals the right side. It checks. Now this is not my solution down here. The solution is still up here. X is equal to 11 is my solution. This was just the check. Now I know for sure that I got it right. And that is how we solve one-step and two-step equations. However, linear equations can have a few extra steps to it. In the next segment, we'll go through some of those other techniques.